discuss how to use a calculator to find binomial probabilities. In your calculator, we need to find the binomial function. It's located under second, and then you hit the bars key. And notice above that is DISTR, stands for distribution. Here are all your probability distributions. We're going to find the Binomial Pdf and the Binomial CDF. So you arrow down. You'll see Binomial Pdf and Binomial CDF. We use the Binomial Pdf when we're talking about the words exactly or equal to. We use a CDF when we're talking about at most. There's three situations where we're going to use the binomial use the calculator for binomial. That'll be exactly or equal to, at most, and at least. Notice there's only two binomial functions, a PDF and a CDF. We can't calculate at least using just a straight binomial function, but we can use complements to help us calculate that, and we'll work on that later on in this video. So we're going to look at the example that we start out with, the rotator cuff example. And it says rotator cuff surgery has a 90% chance of success. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients. So remember, we said that this was X follows a binomial distribution with an N of 3 and a P of 0.9. And for this example, what we're going to do is this. We already know the answer. This was 0.243 from a previous example when we did it by hand. Using the calculator, we're going to pick up on some keywords. The key word here is going to be the word exactly. Exactly tells me I need to do a PDF. So I'm going to go back over here. Clear this out. I'm going to go second, bars, find binomial PDF. Now, click enter on binomial PDF. Depending on what your calculator software is, if you have newer software, you'll see something different. But what they want in PDF is this. They want N first, the number of trials. So the syntax says binomial PDF N, number of trials. Here, our number of trials, or our fixed number is going to be 3. We put a comma right here above the 7 key. If you don't have this, you just press enter to go to the next part. The next part they want is P, probability of success. For us, our probability of success is 0.90. Put another comma. And the last thing they want X, the number of successes. So we want exactly 2 successes. And again, the word exactly means use a PDF. Press a 2 and close the parentheses. And if you press enter, your calculator calculated 0.243 for you, which is what we got by hand a second ago. So our calculator is going to move through this a lot quicker than we can. Let's look at the next example. So we did this about the left-handers. Assume that 13% of people are left-handed. If we select 5 people at random, find the probability of each outcome described below. Let's find the probability that there are exactly 3 lefties in the group. So again, the key word here is the word exactly. And we want exactly 3 lefties. So we'll write that as the probability that X is equal to 3. Because we're using equal, we're going to go to our calculator and do PDF again. So we go second, bars, arrow down to PDF, binomial PDF, enter. We give it the number of trials or the fixed number, in this case is 5, comma. How many, what is the probability of success is 0.13, comma. And how many successes do I want? Well, exactly 3. So it looks like this. We'll press enter. And we get 0.0166. The next example says there are at least 3 lefties in the group. Let's skip over that and go to C, because my calculator can't handle at least. And we'll talk about at least after we do at most. If you look at C, there are no more than 3 lefties in the group. Well, what does that mean? No more than 3 means 3 or less. So that's at most 3. When we do it at most, we write the probability that X is less than or equal to 3. And my calculator can actually calculate that using what's called the CDF. The CDF is called a cumulative distribution function. Cumulative means it calculates up to that point and below. So we're going to calculate up to 3 successes and below it. Let's make this table so we understand what this is actually doing. Right now, X can be equal to 0, 1, 2, 3, 4, or 5 left-handed people. Here we're looking at most 3 left-handed people. So we're going to go to 3 and go back. So we're going to do second bars. This time we're going to go find the CDF. So binomial CDF, and you can use the letters, by the way, A or B if you want to. Press enter. And we're going to calculate up to 3 successes. So the first thing, number of trials, is 5, comma, 0.13, comma. And this time I want at most 3 successes. This is what the calculator is going to calculate. So what the calculator is doing now is adding up all the successes in front of 3, including 3. It's going to add up 0 successes, 1 success, 2 success, 3 success. You could do this one by hand by doing a PDF for each one of those functions. You could do the PDF of 0, the PDF of 1, the PDF of 2, the PDF of 3, and add them all up, and you're going to get this number right here, 0.9987. So when we calculate at most, the calculator can handle that. Now, let's go back to B. It says there are at least 3 lefties in the group. Well, the problem with this is that the calculator only calculates up to and below. We want to calculate on the other side. So at least 3 lefties mean that there are 3, 4, or 5. Well, look, if we look at this table again, if we're including 3, 4, and 5, who are we not including? 0, 1, and 2. So what we can do is we can use the CDF to calculate up to. And this time we're going to calculate up to and include what numbers? Well, you notice it's 0, 1, and 2. So we're going to include up to 2, and we're going to subtract those numbers. We're going to subtract them from 1. Why can we subtract them from 1? Well, we can do that because we know that this part plus this part has to equal what number? 1. So if we take away this part from it, we should get what's left over. So we'll do 1, and in the calculator we'll press 1, and we'll do minus. And this time we're going to do the CDF again. We're going to do the CDF up to 2. Because who are we including? 0, 1, and 2. And that's going to give us who? When we take the 1 minus it, that's going to give us 3, 4, and 5. So second bars. Again, binomial CDF. Because you want to calculate all of those PDFs that are in front of us. So you're going to just use the CDF to do it one time. And so we go N is 5. Your P is still 0.13. This time your X is going to be 2. And notice it's 2 because you're not including the 3. At least 3 means 3, 4, and 5. We need to take away who then? 0, 1, and 2. So we're going to go up to that number we're taking away, which is 2. You press enter. And you get this right here, 0.0179. Let's try the last one. That there is at least 1 left-hander in the group. So at least 1 left-hander. Again, look at the table. At least 1 means what? Well, earlier we talked about at least 1 meaning 1 minus 1. 1 minus none. If you look at this table, you can see that why that's 1 minus none. At least 1 means I have 1, 2, 3, or 5. Anything that's 1 or greater. Who do I not include in that? Well, I'm not including the 0 case. And I can calculate, again, using a PDF or a CDF because you only have 1 number. We're going to use a CDF to get in the habit of that, though. We're going to count up to that 0. So we're including the 0 case and taking it away from 1. So we'll do 1 minus second bars, arrow down on PDF, the CDF, I'm sorry, and we'll do 5, comma, 0.13. And again, this time we're doing 0. We're gonna do just the 0 case and take it away from 1, and that'll give us everybody else. So we do a 0 case, we get this number right here. So remember, when you're calculating an exactly or an equal to, you use the PDF. If you're calculating at most or below, you're going to use the CDF. If you're calculating at least, you have to do 1 minus the CDF.